So first part is manual. We put the robot here and we have 3 objects placed in the path of the camera, and we have some boxes back there that we can go ahead and use to measure the distance from to see how accurate the camera actually is. So let's go ahead and get started with measuring these distances. So the way that we do this first step is by actually positioning the camera here at the left location. You can see in front of that green cube. That green cube is actually the exact location that we'll be taking the picture from our scene, and then we will move this to be 77 centimeters to be placed right on top of the yellow cube, and then we will take the second image. Now we run our algorithm to figure out the difference between the 2 pixels in the x direction. Knowing the distance between our 2 cameras, which was 77 centimeters, we will run this algorithm on the left view, the right view, and get the actual values for each of the objects. So if I run this, okay, it will ask me to select a point. So that we're calibrating the values that the tank is going to back up, rotate, go, turn around, go forward. And it's going to take a picture when it goes there, but for right now, we're just measuring the distance that's going to travel. And to do that, we are playing with these values. So for example, back from the block, 1 and 1 means going to reverse on both motors for 300 ticks on each of the encoders. And on the other side, when you want to rotate left, you move the left motor backwards and the right motor forward. And we're just playing with these values to see what kind of performance we get. So here we go. It looks good, except for the last part where it rotates a little inward, and the angle of the camera looks a little off, so I'm just going to play with those values a little. Just to quickly test the motors, you can see here that I'm trying to achieve 1 exact revolution on the left motor and then 1 exact revolution on the right motor with a 10-second pause in between. Now, I have calculated, and the number of ticks that it would take to do exactly 1 revolution is 1220. So when I run this, we're going to come over here on our robot. Show the robot move from the right block by backing up, rotating left, going a set amount of distance so that it's 77 centimeters, rotate right, move forward to the block. The reason we back up is so that when we rotate, we don't hit the block. And when it, at each block, so right now at the starting position, it will take an image and save it. And after it rotates, goes back and moves to the block again, it will take its second image. Then after it's done taking its images, it will rotate, it will turn back to its original position. So now that we have that, let's go ahead and run it. Okay, in this part, we're going to use the left view and the right view images that was obtained by the robot moving the camera and placing it at the 77 centimeter apart position. And we're going to load those images in and one by one select each of the 4 objects that we have placed. Now we know the actual distances, and we have already calculated what this algorithm would give us if we were to place the camera ourselves manually 77 centimeters apart. So now that the robot did it, it's of course a little off. It's not exactly perpendicular, and it's not exactly at 77 centimeters apart. So we're going to run this, pick the points, and see how much our values differ. So